topic that we hadn't yet learned. But this part of the free response question is still very, very useful. It has us kind of build an equation from, I guess, from scratch like we did in the last part of the problem, but then it also has us kind of apply the equation to the situation more. It's a little bit more of a theoretical and general question, this part, than the last one. So if we start here, it says, or we should go over our notes first. A few things to keep in mind is that oxygen by itself is very, very rare since it's highly reactive. So O2 is much more common than just O. And also, decombustion involves a release of gas. So we'll keep that in mind when we're writing our equation. And I didn't include a method here because it's pretty straightforward. And to write the equation, we'll follow the same process that we did for the last one. Okay, so the solid mercury to oxide decomposes as it is heated in an open test tube in a fume hood. First, we have to write the balanced equation. And for this, we're going to do pretty much the same thing that we did in the first part. So we have to determine our subscripts using our oxidation numbers. They give us that, or they say that mercury has +2, and then we know oxygen always has -2. So if you're undecided if this is -2 or +2, you know that it has to be -2, so this has to be +2 because there's no overall charge, or the overall charge is 0. So our compound is going to look like this. No, I'm sorry, this should be an H. Our overall compound is going to look like this. And then our products, it's a decombustion reaction, so it's going to look something like this. However, like I said, decombustion involves a gas, and it's an open test tube, so it's going to be in the environment. And like I said, oxygen is a highly, highly reactive element, so O2 is much more stable, and it's much more common because it's much more stable. So this is going to be O2. However, now our equation is not balanced. So to balance it out, we have to make this so that it includes 2 oxygens. And then this will have to be 2 Hg and O2. So now there's our balanced equation. Pretty simple, but if you don't know that you have to write O2, that's very easy to make a mistake on. So after the reaction is complete, since it's an open test tube, the gas is obviously going to escape very quickly because this here oxygen is, like I said, decombustion involves the release of a gas. So oxygen is going to be released into the environment. And after the reaction is complete, the mass of the material in the test tube is going to be much less because O2 is released into the environment or into the atmosphere. So you no longer have this part in the test tube, you just have the mercury instead of it being combined together. So, okay, so that's the end of our FRQ. Hopefully this has helped your understanding of reactions, and I tried to put a focus on oxidation numbers because I feel like that was something that I had a hard time with and is a very basic concept, but also one that if you don't know the exceptions to it and the rules to it, it's something that you could get wrong and then have the entire problem be wrong because of. So hopefully this helped, and hopefully you learned a thing or two.